My name is Sergei Sokolenko. I'm a product manager in the Google Cloud. I'll be talking about streaming processing options in the Google Cloud, and my talk will be about 1 hour. Just kidding, just kidding. 20 minutes tops. I have some slides. I'm going to give you an overview of the options, but I wanted to allocate most of the time for the demo at the end. Let me start by just showing you what we have in the Google Cloud. We are present in 20 different regions. Pretty much across the world, we have a great network. It connects lots of CDN locations, and we also have lots of locations for dedicated interconnect. The number of services we offer to customers span infrastructure as a service and go up to managed services. This slide just shows you the big data processing services we have. It doesn't show you things like compute engine for infrastructure or storage or databases. So this is just the big data processing services. We are starting with data ingestion, Cloud PubSub. You can run data transfer service into BigQuery, as well as the storage transfer service. Then for streaming processing, we have Dataflow that runs on Beam. We have Dataproc that offers you Flink and Spark processing. And then we have, many of you might heard of BigQuery. Just by a show of hand, who had the chance to try out BigQuery in the past? You know, a few of you. This is typically what customers start with when they go to the Google Cloud. They've heard of BigQuery, they would like to try it out. And then once they try it out, they want more, they come for other processing services. Lastly, we are also very strong on the AI front and machine learning. We offer the Cloud AI platform. TensorFlow is obviously a very popular product that originated in Google. Then we have a set of horizontal services, things like Data Fusion for ETL visualizations, or Data Catalog for schema storage and metadata, as well as Cloud Composer for orchestrating pipelines. If you heard of Airflow, Composer is managed Airflow. Now, when you go and build your streaming pipelines in the Google Cloud, you will typically use a combination of the following services. For ingestion and distribution of messages, you'll typically use Cloud PubSub. Then for aggregation, enrichment, and detection of patterns in your streams, you would use Dataflow Streaming. We also offer open source services and tools in the Google Cloud. You can use Kafka, either self-managed or managed by Confluent. And you can also use Spark and Flink running on Dataproc. Now, once you've aggregated and massaged your data and you're ready to save it into an analytical store or do some machine learning, you'll typically use the Cloud AI platform or BigQuery for data warehousing or Bigtable. Now, there's always a little bit of batch in every streaming pipeline. And so for that, we offer Dataflow Batch. It's quite popular with customers. And I already mentioned Cloud Composer. Let me spend maybe a minute each per service, just giving you highlights of what they are. Again, remember, it's a demo. There's a demo at the end, so it will be fun. Cloud PubSub scales really, really well, from just a few messages to millions and billions of messages. It offers you the familiar publish-subscribe pattern, and it's global. But you'll have the option of keeping it local for your region. And the last great quality about PubSub is it's really integrated with all the other services that the Google Cloud provides. Dataflow offers you unified batch and streaming processing. It's the evolution of multiple research papers published by Google, things like Millwheel on the streaming side, as well as Flume Java on the batch side. It offers exactly once processing when used together with PubSub. And it's really about serverless and allowing customers not to think about managing clusters. Some of you might like managing clusters, and that's great. Others who don't like managing clusters, well, we have Dataflow for that. There's enough complexity if you would like to really write complex pipelines. There's enough work for everyone. Dataflow is based and is using the Apache Beam Sdk as its SDK. Apache Beam was originated by the Dataflow team, and then it was open sourced. It's now a very popular open source project. Similar to Flink, it's one of the top 3 Apache projects second year in a row by the dev activity, number of commits, as well as the communication on dev and user lists. And it offers a range of languages: Java, Python, Scala, SQL, and Go. And lastly, the most important quality of Beam is it strives to be this portable layer that allows you to, more specifically, write everything, have all of the APIs available for all of the languages that you want to use, as well as run your pipeline written in the language of your choice in a variety of execution environments. So you can run your pipeline in Dataflow in the Google Cloud. You can run it on Flink, either in a different cloud or on premises. You can use Spark, Apex, IBM Streams, and a bunch of other runners. Last but not least, I also wanted to mention BigQuery. BigQuery is our premier data warehousing tool. It's great for streaming analytics if you want to follow the ELT pattern, where you extract and load into BigQuery and then do all of the transformations in BigQuery. It offers the streaming API, which you can use to insert data into the data warehouse. And it's great for real-time visualizations. So dashboarding is really well supported. We have the BI engine, we have Looker. We recently acquired Looker, and it will become part of the package in the future. Now, today we are announcing the Flink operator that was for Kubernetes that was released by our Dataproc team. Dataproc is focusing on a fully managed Hadoop, Spark, and Flink environment, and the Dataproc team has released today the Flink operator for Kubernetes. It allows you to create a control plane for running Flink on Kubernetes, and all of the code and instructions is available on the Google Cloud's GitHub. Well, with this, let me transition and motivate my demo. When I go and talk to customers, they sometimes tell me streaming processing is not easy. It requires a special set of skills. It makes you really think about watermarks and late arriving data and how do you analyze things in stream. So it's not as easy as, for example, batch processing. So we set ourselves the goal of making streaming as simple, perhaps even simpler than batch. And one thing that we realized, and many in this industry realized, that SQL provides this nice abstraction layer for defining what you actually want to process. So we created a user experience that is integrated with BigQuery, where many customers start. And in this user experience, customers go in, they develop their streaming pipelines in SQL, in BigQuery, and then they have a choice of where they want to run their SQL statements. They can run them against BigQuery, they can run them against Dataflow. And depending on whether there's a stream involved, all of the streaming pipelines go to Dataflow. And all of the batch pipelines, you actually have a choice. You can run them on BigQuery or in Dataflow. So I wanted to show you a demo that takes a stream of sales transactions. Just imagine you are a website, or perhaps you operate a point-of-sale system, a retail location, a set of retail locations. So you have a stream of sales transactions. Your typical who purchased the good, what product was sold, what is the amount of the sale, and where the location of the sale was. So I want to take the stream and I want to run some useful reporting and analytics for my sales managers. My company is divided into 7 sales regions, and I want to give the sales managers in each region a report and a real-time dashboard that tells them in near real time how much sales they're making. So I'm going to take this the stream, and it's in a pub subtopic. I'm going to enrich it because my original stream does not have the sales region. That's metadata, and metadata I store in BigQuery. I'm going to take the stream, I'm going to join it with BigQuery, and I'm going to dump all of my results back into BigQuery and build a dashboard on top of it. Enough talking. Let me actually switch to demo mode. So this would be if you're familiar with BigQuery, if you use BigQuery, this is the interface you would start with. We have a query editor where you type in your SQL statements. and then you have access to some job history and navigational information. Now, all it takes to create a SQL statement and run it against Dataflow is going into settings and choosing Dataflow engine as my destination. And then the UI transforms. You get different options now. Instead of running the query against BigQuery, you can run a Dataflow job. That's right here. I'm a bad typer, especially during demos. So I'm going to use a SQL query that I ran previously. Pick a job that I previously executed and just pull the query back into the query editor. It's the same SQL statement I showed you on the slide. Let me explain what's going on here. It will take a pub/sub topic, which is similar or equivalent to a Kafka topic. It will join all the records in that, all the messages in that topic with a BigQuery table. That's my metadata lookup. Here's my join condition. By the way, this is a US-based demo, so the join condition is based on US states. If you're familiar with US states, we have 50-ish states, and we'll map them all to 7 sales regions. I want to show you the schema of the pub/sub topic just to visualize what data we are dealing with. That's another quality of Dataflow SQL. We integrated with schema storage. You can define a schema for a pub/sub topic, and magically now you can run SQL statements against it. So this topic has a payload. That's the main attribute of that topic. And in the payload, I have my sales transaction, which contains the time of the sale, the person who purchased the good, first name, last name, the city and the state, the product that was sold, and the sales amount. Let me also show you the contents of my mapping table so that you can actually visualize the data we'll be joining with. It's located in this data set. And it's a very simple table, has 50 records in it. A state of Missouri, for example, is mapped in my organizational hierarchy to sales region 1. South Carolina is also sales region 1, but then, for example, Delaware is region 2. Well, great. So now we know what the data is. Remember the goal that I set myself? I want to give a real-time dashboard for my sales managers. And for that, I need to aggregate my data by the sales region. And I need to timestamp the time windows. I need to window the data and add a timestamp to the output, and then sum up all of the sales. That's exactly what's going on here. I'm grouping by the sales region. I'm also grouping by I'm creating fixed windows that will subdivide my data set into 5-second long windows. And in the output, I am specifying the region, the beginning of the time window, my timestamp, and the sum of all the sales. That's all I need to know to run the job. When I run the job, BigQuery/Dataflow will ask me for a couple of parameters. It will ask me where do I want to output my results. And let me just use a new table name here. So I want to store all of my results in a BigQuery table, because once I have in BigQuery, I can build a dashboard on top of it. Great, so within a second or two, a new Dataflow job will be initiated. I can open it up. And I will see the graph. It takes about a minute or two to start the job. I didn't want to wait in the demo, so I ran the job just before coming here. This is what you would see if you waited for a minute. The bulk of the graph is contained in the top box. You'll recognize the shape of my SQL statement. I have 2 inputs, right? Remember, pub/sub and BigQuery were my inputs. One of them is BigQuery. Well, this is actually the pub/sub one. They sometimes change depending on the location and the positioning in the graph changes. And this is my BigQuery input. I'm going to read all of the inputs into the join. I'm going to run the join, and it's the Beam optimizer will choose a side input join. That's the most efficient one to enrich a stream, unbounded stream with a very small table. And at the end, I will aggregate into a sum, and I'll actually do a windowing operation in between here as well. It's somewhere here. Yeah, here's my windowing operation. This one will create 5-second long windows. And at the end, I have a summing up operation. All of the data, once it passes the data flow, it will be output to BigQuery. And to prove you that I actually do have data exiting the pipeline, I also opened up another BigQuery editor. And the previous job is actually writing in the Dataflow SQL table 09. And if I ran a statement just doing a select star from it and ordering by period start is my timestamp, just watch what will happen in the output. And let's give, so note the latest timestamp. If we rerun the query after 5 seconds, we should see new records there. Maybe 5 seconds didn't pass. Let's see. Oh, it's because I'm sorting by the wrong. I need sort in descending order. Let's do the same test. So remember the timestamp. So it was the latest record was created at second 35. If we rerun, so it's now 45. As you can see, data gets created. Well, what can I do with this data? My goal was to create a dashboard, and I'll do exactly that. Google provides multiple ways of visualizing data in BigQuery, streaming data as well. I can use Sheets, and I can use Data Studio. And there's also a large range of other tools for visualizing, Tableau, Looker, other tools. I'll use Sheets because it's the most convenient and quickest way of creating a dashboard. I just created a connected sheet. It reads directly from BigQuery. I can create a chart. This chart will contain my real-time data, and I'll pick the line chart. I'll add perhaps, I'll do a kind of a trend chart for my sales for a particular region by selecting period start as my x-axis. That's my time dimension. And in my series, I will pick amount, and I will set the filter to a particular sales region. Region 1. And that's all I needed to do to build a real-time dashboard. Now what will happen is I'm going to get a chart, and I can let my sales managers use their preferred spreadsheets and just go and refresh the data as it comes in. So that was all I needed to do to build real-time dashboarding in BigQuery and Dataflow. Just to summarize what we all saw and saw in the demo as well as on slides, you have options in the Google Cloud to do stream processing. You can use Dataflow, you can use Dataproc, you can also do self-managed Flink and Spark and Kafka. There's a very easy path for you to start with streaming by using SQL and Dataflow SQL. If you have any questions, I would be happy to answer them. Perhaps we can take a question or two. I think we have maybe 30 seconds left. And later on, I can also answer questions after the talk.